Lesson 6.5 is about inequalities for two triangles. Okay, this first theorem is called the side-angle-side inequality theorem, and this has to do with when we're comparing sides from two different triangles. If I have two triangles where I have two sides in one triangle congruent to two sides in the other triangle, as I do with these two triangles here, then I have to look at those included angles. And it's going to end up logically that the side that is opposite the larger of the two included angles is going to be greater than the side that's opposite the included angle that's smaller. So the theorem is that the side opposite the bigger included angle is going to be longer than the side opposite the smaller included angle. And what it means is that this side on the left is bigger when compared to this side on the right-hand triangle. So then from that, the second theorem follows logically, the side-side-side inequality theorem, which is just sort of the reverse. And this is that, that if I have two triangles with two congruent sides and a third side that's not congruent, I think it stands to reason that the angle opposite the longer side is going to be bigger than the angle opposite the smaller side. So the theorem is that the included angle that's opposite the bigger side between two triangles is greater than the measure of the included angle opposite the smaller side when I am comparing the angles in two different triangles. Okay, so in this first example I have two triangles with two congruent sides and I want to compare the included angle. Well, I can see that across from the 15 side is going to be bigger than the angle measure across from the side that's 14. So I can say for sure that the measure of angle A is going to be greater than the measure of angle D, and I'm using the side-side-side inequality theorem. Okay, in the next example, I've got to compare sides. And so what I'm looking at here is that D is a midpoint of side AC. I can see that because AD and DC are congruent. And I'm given that measure of angle 1 is greater than measure of angle 2. Well, I can see that both of these two triangles on the left and right share the common side of BD. So if I kind of just redraw those, I'm looking at two triangles that look like this, but I'm told that the bigger angle is angle 1 and the smaller angle is angle 2. So I now know that opposite angle 1 has to be bigger than the side length opposite angle 2. So I can conclude that side AB must be longer than side BC by the side-angle-side inequality theorem. And the reason is, just to restate that, the bigger side is opposite the bigger included angle than the smaller side, and the smaller side is opposite the smaller included angle. Okay, in our next example, we're going to compare angle 1 to angle 2. This figure looks like a parallelogram, but it's not, because I see that I've got the side on the right, 6, is bigger than the side on the left, which is 5, so I'll be using that. Okay, so what do I know? Well, these two sides of 10 are the same measure, and this common side is the same measure. So if I redraw those two triangles, separate out the common side, it looks like this. And I've got the side that's 5 here and the side that's 6 here. So what I know is that this side opposite angle, the longer side, so in other words, angle 1 has got to be greater in measure than angle 2. So I can say for sure that the measure of angle 1 is greater than the measure of angle 2, because angle 1 is opposite the bigger side, and that would be using the side-side-side inequality theorem. Okay, for this next example, we've got a proof. And what we've got is two triangles, kind of side by side. They share a common side there. They're both isosceles triangles. And I've been given that the three segments TU, SU, and SV are congruent. And what I've got to prove in this one is that side ST here is bigger, is greater than in length than side SV. And in order to do this, I'm going to have to use the fact that there's that SU segment in the middle, but I'm going to have to ignore it a little bit and look at this as one big triangle. And I'm going to be evaluating the big side. If it's bigger, I'm going to have to prove that angle V is greater, because it's opposite that big side, than angle T in measure, which is opposite the smaller side. So I'm aiming to prove that angle V is greater than angle T. So let's see what I've got. First of all, this isosceles triangle here tells me that these two base angles are congruent. And then I know on the other triangle on the left that these two angles are congruent to each other. So I can write that out as the measure of angle SUV is congruent to the measure of angle SUV, or SVU. And that is using the isosceles triangle theorem. Okay, the next step is really the key logical step in this whole proof. Remember, I'm trying to prove that angle V is greater than angle T. Well, angle V and angle SUV are the same measure, but I can see that this is an exterior, that angle SUV is an exterior angle of the triangle TSU, of the triangle on the left. And so I know that it has to be greater than angle T and angle TSU. I know it has to be greater than angle T. So my next step is to say that the measure of angle SUV is greater than the measure of angle T. And that would be using the previously learned exterior angle inequality theorem. That the exterior angle is greater than either the measure of either the two remote interior angles. Now, because I know that SUV and SVU are the same measure, I can now substitute and say, well, substitute into the step 3 the measure of angle SVU, which is what I was trying to prove, that measure of angle V out there, is greater than the measure of angle T. And that would be substitution. So lastly, now I know that the side opposite angle SVU, which is ST, has to be longer or bigger than the side opposite angle T, which is over here. So now I have proved my case, and that my reason would be that when comparing two triangles, that the side opposite well, actually I'm in one triangle because I'm looking at the big triangle TSU, that the side opposite the bigger angle must be, bigger angle must be greater than the side opposite the smaller angle. And that is it.